All right, in this video, we're going to be looking at section 2.6, problem number 13. And in problem number 13, they give us this piecewise function. And they tell us that this acceleration due to gravity, this lowercase g, varies with the height above the surface of the Earth in a certain way. And this is the way in which it varies. And they first want us to sketch a graph of g against r. So in other words, r is my independent value, lowercase r. G is my dependent variable, that's my output. All right, let's take a close look at this function here and see what we're working with. We're told that uppercase G is the gravitational constant, m is the mass of the Earth, and uppercase R is the radius of the Earth. So in other words, G and M and R are all constants. They're not varying. That's why only the lowercase r and the g are what we see in our graph. The lowercase g, the gravitational, the gravity. So, I'm sorry, g is the acceleration due to gravity, and r is the height above the surface of the Earth. All right, so the important part here is that since g and m and r are all constants, this here equates to a single value. So what we have is a single quantity multiplied by r, our variable r. That's a linear function. When that quantity is, when r is 0, let me go ahead and try to graph this now. When r is 0, that full quantity, whatever it is times r, would give me a g value of 0. Then this would, as r increases, this would be the linear function that goes up like this until we hit some value of uppercase R. So as long as the variable r is less than this given value of uppercase R, we just have this linear function. All right, now, once the variable r is equal to or larger than the constant r, then we have this situation that we need to look at, which is here. Again, since g and m are constants, what we end up with is basically something that looks like the 1 over r squared function just being multiplied by some scale factor of gm. 1 over r squared, we know has this type of a shape. So that's my general looking graph. I have the linear function until r is equal to uppercase R, and then after that I have this rational function 1 over r squared multiplied by gm, of course, which has this look here. All right, now part B says, is this g a continuous function of r? And so we need to check for continuity. We know that linear functions are continuous, so we know that this portion of the function is continuous. We know that 1 over r squared is continuous as long as lowercase r is not equal to 0, because we can't have 1 over 0. And since we're not letting lowercase r be equal to 0, that variable r in this case is always greater than or equal to the value of uppercase R. We know that this portion of the graph is a continuous function. So only spot we have to worry about is right here where those two graphs meet. Do they actually meet? at the same exact location. So is G at R equal to the limit as R approaches R of G of R? Is that the case? Okay, so let's look and see. Well, I have GM over R cubed times R. And so when lowercase r equals uppercase R, that would become GMR over R cubed, which becomes GM over R squared. So we do know that the limit here, right, is approaching GM over R squared. And we also know that when lowercase r actually equals uppercase R, we're told that the function is equal to this GM over R squared. And so, yes, we do have continuity because the function evaluated at that value of R is equal to the limit of the function at that value of R. So we are good. We have continuity. We have, yes, it is a continuous function. We have continuity. So now let's look at part C. Part C asks us, is G differentiable function of R? And this is where we run into a little bit of a problem, because at this sharp corner right here, we actually don't know what the tangent line would be at that location, right? So there's infinite number of tangent lines that could happen at that point. Is it coming off this way? Would you say the function is coming off this way? Would you say the function is coming off this way? So the tangent line, I mean. And so therefore, since there's a sharp corner there, we say that G is not differentiable over R because of that one point. Everywhere else, the function is differentiable, but at that one point, at that sharp corner, it is not. And so therefore, the function G is not differentiable.